Welcome. In this particular video, we'll be solving trigonometric equations involving secant part 2. Let's take a look at our example. Solve the equation given below for theta greater than or equal to 0 less than 2 pi. Here we have secant of theta plus 3 pi over 4 is equal to 2. The first thing we're going to do is to try to solve a simpler equation. So let's go ahead and introduce a new variable based on this particular input. So let alpha be equal to theta plus 3 pi over 4. Now, this will enable us to rewrite our original equation as follows. Secant of alpha is equal to 2. The next step is to rewrite this equation using the definition of secant. Secant is 1 over cosine. So we can say that this equation is equivalent to 1 over cosine of alpha is equal to 2. Now, taking the reciprocal of both sides of the equation, we get an equivalent equation as follows. The reciprocal of 1 over cosine of alpha is cosine of alpha, and the reciprocal of 2 is 1/2. So now we can say that we're looking for any angles alpha that will have an x-coordinate corresponding to them of 1/2. So what we need to do is to use the unit circle here on display that will have the points that will give us an x-coordinate of 1/2. So we come around the unit circle and we find any point that has an x-coordinate of 1/2. That happens to be here. Pi over 3 and the reflection across the x-axis, which is 5 pi over 3. So we can say that alpha can be either pi over 3 or 5 pi over 3. Now, using both of those values, we're going to solve for theta. So let's take a look at the first value. Using alpha is equal to pi over 3, let's solve for theta. How are we going to do that? Well, we're going to substitute in the expression for alpha. Alpha is simply theta plus 3 pi over 4, and the right-hand side remains the same, so we have pi over 3. Now, to solve for theta, let's go ahead and subtract the 3 pi over 4 from both sides. That leaves you with theta is equal to pi over 3 minus 3 pi over 4. Now, we need the common denominator. The least common denominator here will be 12. So let's multiply this one by 4 over 4 and this expression by 3 over 3. So we get 4 pi minus 9 pi becomes negative 5 pi, all of it over 12. Clearly, this is an angle that it's not on the given interval from 0 to 2 pi. So what we're going to do is to add the period of the original function here. So recall that the period of secant is 2 pi. So we take the 2 pi and we're going to divide that by the absolute value of the coefficient of theta. And the coefficient of theta here is 1. So we take the absolute value of 1, which is 1. So you have that the period is 2 pi divided by 1, which is 2 pi. So what we're going to do is to take theta, the next theta, to be negative 5 pi over 12 plus the period of 2 pi. And to get the common denominator, let's multiply the 2 pi by 12 over 12. So you have negative 5 pi plus 24 becomes positive 19 pi all over 12. So that is one of your solutions here. To figure out the next solution, we're going to use the next value for alpha. So using alpha equals to 5 pi over 3, solve for theta. Let's go ahead and do that. So to solve for theta, once again, what we're going to do is to substitute in the expression for alpha in terms of theta. So we have that alpha is theta plus 3 pi over 4, and all of that is equal to 5 pi over 3. So let's go ahead and subtract the 3 pi over 4 from both sides of the equation. So we have minus 3 pi over 4 and minus 3 pi over 4. This leaves you with theta being equal to 5 pi over 3 minus 3 pi over 4. Once again, looking for the common denominator, we are going to multiply this first expression by 4 over 4 and the second expression by 3 over 3. So 5 times 4 gives you the 20 pi over 12 minus 3 times 3 times pi gives you 9 pi over 12. So the next value for theta, or the other value for theta, will be 20 pi minus 9 pi. It's 11 pi all over 12. And that is another angle between 0 and 2 pi. So we can say, therefore, that the values for theta that will satisfy this particular equation will happen to be 11 pi over 12 and 19 pi over 12. And those are the solutions to the original equation. And this concludes our video on solving trigonometric equations with secant part 2. Thank you for watching and have a wonderful day.